Hey guys, today we're going to be finishing up chapter 7. We've got 2 lessons left here in the chapter, lessons 6 and 7, that, like I said in the last video, we're going to be finishing up fairly normal here, going through the notes together. You guys will have a couple assignments that you'll end up doing and just sending me pictures of. And then when we're done with this chapter, moving on into the next chapter, we'll be switching things up a little bit. And there's more information in the email that this video came in as far as what you'll need to do to get ready for those lessons. So let's go ahead and get started today. These lessons are fairly short here. The first one is on multiplying polynomials. So last time we talked about adding and subtracting polynomials. Today we're going to be multiplying them. So remember, a polynomial is any set of terms that are all monomials that are added or subtracted from each other. So what we're going to be starting with today is multiplying binomials together. So remember, a binomial has 2 terms in each polynomial. And the method that we use for multiplying polynomials, or binomials in this case, is called the FOIL method. It is just a shortcut version of the distributive property when you're having to distribute multiple terms in. And FOIL stands for first terms, outer terms, inner terms, last terms. So that's the order that we will always multiply in order to multiply 2 binomials together. So in this case, we would multiply our first terms first, then we would multiply our outer terms, so the first and the last term, then we would multiply our inner terms, and then we would multiply our last terms. Again, it's really just another method of using the distributive property. So let's go ahead and walk through one of these. This first one we're going to do is x minus 5 times x plus 7. So again, FOIL. F means we multiply our first terms. So we're distributing this x into this binomial right here. So our first terms, x times x, gives us x squared. Then we distribute the x to the 7. We're multiplying our outer terms. X times 7 gives us plus 7x. Then we move on to our inner terms. Negative 5 times x gives us negative 5x. And then our last terms, negative 5 times 7, gives us negative 35. Then we need to get it down to its simplest form. So we combine our like terms. We end up with x squared plus 2x minus 35. So we got that 2x by combining 7x and negative 5x to give us a positive 2x. That can't be simplified anymore, so that would be our final polynomial. Anytime you multiply 2 binomials by each other, you should end up with a trinomial as your answer. So let's go ahead and do another one then. This time, so on that last one, our leading terms had a coefficient of 1. This time they have different coefficients. But we're going to take the same steps here. So we multiply our first terms, 2y times 6y. Remember, we multiply the coefficients. 2 times 6 gives us 12. Y times y gives us y squared. Then we do our outer terms. 2y times negative 7 gives us negative 14y. Then our inner terms, 3 times 6y gives us a positive 18y. And our last terms, 3 times negative 7 gives us negative 21. And then again, we need to combine our like terms. So we end up with 12y squared, negative 14y plus 18y gives us a positive 4y minus 21. And that would be our final polynomial that we would end up with. So again, the steps there are fairly simple for multiplying binomials. Multiply your first terms, then your outer terms, then your inner, then your last. Always remember FOIL, first, outer, inner, last. Then combine our like terms to get our final simplified polynomial. Remember, these should always be written in descending order. So we're starting with the y squared, then the y, then the constant without variable. So moving on here, the area, A, of a trapezoid is 1/2 the height, H, times the sum of the bases, B1 and B2. So before I go any further, I'm going to go ahead and write that out in an algebraic equation. So the area A is, remember, is always means equal, 1/2 the height, so 1/2 times the height times the sum of the bases, B1 and B2. So we would put in parentheses B1 plus B2. So that equation right there is how we will find the area of a trapezoid. So they want us to write an expression for the area of this trapezoid right here. So what I'm going to do is I'm going to take this equation we just wrote. Oops. I'm going to take that equation that we just wrote and plug in the terms that were given over in that trapezoid. So the area is equal to 1/2 times the height. The height in this case would be that x plus 2 times the sum of the bases. And the bases are 3x minus 7 plus 2x plus 1. So now we've plugged it, we came up with our equation, we plugged in our numbers, now we're just going to simplify this equation. So I'm going to do two steps at once here. I'm going to go ahead and distribute my 1/2 into my binomial. So 1/2 times x gives me 1/2 x, 1/2 times 2 gives me a positive 1. I'm going to put that in parentheses. Then over in this one, I'm going to combine my like terms. So 3x plus 2x gives me 5x. Negative 7 plus 1 gives me negative 6. So now you see we've got two binomials. We're going to go back to what we were doing on that last slide, and we need to multiply these together using the FOIL method. So I'm going to do my first terms, 1/2 times 5. I'm going to go ahead and write that for now as an improper fraction. Remember, anytime you do a fraction times a whole number, you just multiply the whole number by the numerator. Denominator stays the same. So we would do 5 times 1 is 5 over 2. X times x gives us x squared. Then our outer terms, 1/2 x minus 6, or times negative 6, sorry, would give me a negative 3x. Inner, 1 times 5x gives me 5x. And last, 1 times negative 6 would give me negative 6. So then, combining my like terms, negative 3x plus 5x is going to give me a positive 2x. Subtract 6. This would be our polynomial that we would use in order to find the area of that given trapezoid. Now this 5 over 2x squared could also be written as 2.5x squared. Either way would work. So that was using a trapezoid. This time we're going to be working with a triangle. So write an expression for the area of a triangle with a base of 2x plus 3 and a height of 3x minus 1. Now the area of a triangle, if you remember back, is 1/2 times the base times the height. So in this case, again, we're just going to take that equation and plug in the numbers that they give us. So the area is equal to 1/2 times the base, which is 2x plus 3, times the height, which is 3x minus 1. Now, when we're doing these, the order doesn't really matter. Going back to our properties of numbers, we're multiplying all three of these together. So when you multiply, the order that you multiply in does not matter. So we could multiply 1/2, distribute 1/2 into the 2x plus 3. I'm going to start by leaving the 1/2, and I'm going to go ahead and FOIL my binomials together. So first term's 2x times 3x gives me 6x squared. 2x times -1 gives me -2x. The inner terms, 3 times 3x gives me a positive 9x. And the last, 3 times -1 gives me a -3. Now, just like we've been doing, we need to combine our like terms. So we still have the area is equal to 1/2 times 6x squared. -2x plus 9x is going to give me a positive 7x minus 3. Now we need to distribute this 1/2 into our polynomial. So the area is equal to 1/2 times 6x squared gives me 3x squared. 1/2 times 7x gives me a positive 7 over 2x. And 1/2 times -3 gives me a -3 over 2. And that would be our polynomial right there. Again, 7 over 2 could be written as 3.5. 3 over 2 could be written as 1.5. I would take either answer there. So that was the last two slides. We've been multiplying, just working on multiplying two binomials by each other. Here we're going to be working on multiplying binomials and trinomials. So we're going to do one example that's a binomial and a trinomial. And we're going to do one example that has two trinomials multiplied. So here we're going to be using the same basic method of that FOIL method, but it's going to be a little bit different because adding in that extra term in our trinomial makes it so that we're not using the exact term FOIL anymore. But we're still using that same method of distributing. So in this case, in order to multiply a binomial and a trinomial, first we're going to distribute this 4x, the first term, into all of the terms of this trinomial. So 4x times 2x squared, 4 times 2 gives me 8, x times x squared gives me x cubed. Then I'm going to continue on, 4x times -5x gives me -20x squared, and 4x times 3 gives me a positive 12x. Now I need to distribute my 9 into this trinomial. So 9 times 2x squared gives me 18x squared. 9 times -5x gives me -45x. And 9 times 3 gives me a positive 27. Now I need to find any like terms and combine them. So I've got a -20x squared and a positive 18x squared. I've got a positive 12x and a -45x. So I'm going to have 8x cubed. Then I combine -20x squared plus 18x squared would give me -2x squared. 12x minus 45x would give me a -33x. And then I've got my 27 at the end. To make sure you're done, you want to check to see first, do you have any like terms that can still be combined? In this case, we don't. And then the last thing, make sure it's in descending order. So we've got x cubed, x squared, x, and our constant. So that is in descending order. That would be our final answer right there. So then the same thing when we're multiplying two trinomials by each other, we're still just distributing. It's just going to add some more steps in. So first, m squared times 4m squared would give me 4m to the 4th. Remember, we add our exponents. M squared times -7m would give me -7m cubed. And m squared plus 5 would give me positive 5m squared. Now I'm going to distribute my 2m. 2m times 4m squared would give me a positive 8m cubed. 2m times negative 7m would give me negative 14m squared. And 2m times 5 would give me a positive 10m. Now we have to distribute one more time. We have to distribute this negative 3 in. So negative 3 times 4m squared would give me a negative 12m squared. Negative 3 times negative 7m gives me a positive 21m. And negative 3 times 5 gives me a negative 15. So now that we've done all of our distributing, you see we have 3 trinomials that we're combining with addition or subtraction, but we can do it a little bit easier by just combining our like terms. So we've got, hold on a second. So we've got a negative 7m cubed here, and we've got 8m cubed. Then m squared values, we have 5m squared, negative 14m squared, and negative 12m squared. Then our m's, 10m, and 21m. So we want to combine those like terms. We'll have 4m to the fourth. Negative 7m cubed plus 8m cubed would give us a positive 1m cubed. 5m squared minus 14m squared gives us negative 9m squared. Minus 12m squared gives us a negative 21m squared. Then 10m plus 21m gives us 31m, and we subtract our 15 at the end. Again, we want to check to make sure there are no like terms that can still be combined. Make sure it's in descending order, and that would be our simplified polynomial in this case. So then the last couple slides are going to be on lesson 7, which is special products. So this is just looking at multiplying polynomials, but looking at some special circumstances that if you can remember these patterns, it can make things a lot easier as you move on in math to be able to not have to sit there and FOIL everything out. You'll be able to just see, okay, this one is a square of a sum. I know how that needs to come out, and I don't actually have to FOIL it. So to start here, I'm going to show you with foiling why this works. So the square of a sum is any time you have a plus b, any number plus another number, or term plus another term squared. This could also be written, it won't always be like this where it's 4y plus 5 squared. It might be written as 4y plus 5 times 4y plus 5. But if you see that, you can simplify that to 4y plus 5 squared. And the pattern that this will always come out to is a squared, or your first term squared, plus 2 times a times b. So you would multiply your first term by your second term, multiply that by 2, and then plus b squared, or your second term squared. Now, if I go ahead and FOIL this, I'm going to get 4y times 4y, which gives me 16y squared. 4y plus 5 is 20y. 5 times 4y, we add another 20y. And then 5 times 5 gives me 25. Now, if you look at this, 16y squared is a squared. 4y squared gives us 16y squared. Then if we combine our like terms, 20y plus 20y, here 20y is a times b, 20y is a times b, so if we do a times b and multiply that by 2, it would give us 40y. And then the 25 at the end is 5 times 5, which is our b value, so b squared. So if we look at it without all of the without all of the foiling, remember, your first term is your a, your second term is your b. So if we look at this pattern right here, a squared would be 4y squared, which gives us 16y squared, plus 2 times a times b. So if we do a times b, that would give us 20y, times 2 gives us 40y, plus b squared, or 5 squared, which is 25. So again, it takes out those steps of having to write it out, FOIL it, combine your like terms. As long as you can remember that pattern, you're going to be able to just see, oh, I've got a square of a sum. I can just follow that pattern and get my solution. So let's do that here. 3x plus 4y quantity squared. So it's a sum and we're squaring it. It fits our square of a sum pattern. So we've got our a term and our b term. Our pattern would be a squared. So in this case, 3x squared, 3 squared is 9, x squared, plus 2ab. So if we multiply a times b, it would give us 12xy times 2 would give us 24xy, plus b squared, b is 4y, so b squared would be 16y squared. And that would be our polynomial. Let's walk through one more real quick. 8c plus 3 squared. So again, we have our a term and our b term. A squared would give us 64c squared plus 2ab. AB would be 24c times 2 would give us 48c, plus b squared would be 9. And there we go. The next slide is the same thing, except instead of a square of a sum, it's a square of a difference. So instead of a plus b squared, we're doing a minus b squared. Our pattern, if you take a look at this, looks pretty much the same. The only difference is after our a squared, we're subtracting 2ab instead of adding 2ab. Other than that, this one is exactly the same. We're still looking for that a and b term. We go a squared, so in this case 36p squared. Now we're doing minus 2ab. So ab would be 6p times 1 is 6p, times 2 would be 12p, plus b squared, which is 1. Walk through two more of these here. So a minus 2b squared. Again, we have our a and b terms. A squared would be a squared in this case, minus 2ab. A times b would be 2ab, times 2 would be 4ab, plus our b squared would give us 4b squared. Now this last one gets a little bit different because we have an exponent within our square of a difference. But we would still do the same thing. We have our a and b terms. Remember, if we have to do a squared, which in this case would be 5m cubed squared, remember that squared, we have to square everything within the parentheses. So we're really distributing that square into every term there. So 5 squared would give us 25. M cubed squared, remember, since we're raising an exponent to a power, we multiply them. So this would give us 25m to the 6th minus 2ab. In this case, a times b would be 10m cubed n. Multiply that by 2, we get 20m cubed n. And then we would add b squared, which would be 4n squared. And that would be our final polynomial right there. Then our last special product here is the product of a sum and a difference. So in order to find the product of a sum and a difference, or what that'll look like, on the last couple, the square of a sum was like 5x plus 3 squared. Difference of a sum, difference of a square, 5x minus 3 squared. In this case, instead of having a plus b times a plus b or a minus b times a minus b, we have a plus b times a minus b, or it could be the other way around. The key here is that your a and b terms have to be the same in both of them. So this could be like x plus 2 times x minus 2. If it were x plus 3 and x minus 2, that would not work because your b values are not the same. So here it could also be x minus 2 times x plus 2. Now this one is actually a much easier pattern to remember. Anytime you have the same a and b values, one is a sum, one is a difference, your pattern, your solution that it'll always come out to is just a squared minus b squared. So in this case, we have 11v minus 8w squared times 11v plus 8w squared. So we have the same a and b values in both of them. One is subtracting, one is adding. So we're just going to take our pattern here, a squared. So our a is 11v. 11v squared would give us 121v squared minus b squared, which in this case b is 8w squared. If we square that, 8 times 8 gives us 64. W squared, and then you have to square that, so we would multiply 2 times 2, which would give us a power of 4. And that is all you have to do there. That would be our solution. So let's just do one more of these. Let's go with this one here. Make sure our a values match, 3n and 3n. Our b values match, 2 and 2. One is a sum, one is a difference. So we know it's going to come out to a squared, which in this case would be 9n squared, minus b squared, which in this case would be 4. And that would be our solution right there. That's all you have to do to solve that. So again, that's multiplying polynomials and then learning some special products that can help you be able to take some shortcuts, not have to go through all the steps of foiling. Homework is right here for, let's see, this was 7.6 and 7.7. So for 7.6, you're going to be doing page 401, numbers 1 through 11. For 7.7, you're going to be doing page 407, numbers 1 through 6 and 9 through 11. This information, these notes will all be up on Schoology for you guys to access. Again, make sure you read the email carefully so you can see what you need to do to prepare for what we're going to be doing moving forward. And again, feel free to email, text, call. I'll be sending out an email also. I'm going to try and figure out a time to have just some open hours that I'll be available on Zoom if you guys want to hop on and ask me any questions, anything like that. We can do that as well. But yeah, those are those lessons, and be looking for more information from me moving forward.